Welcome to this beginner-friendly guide on asynchronous C# for responsive Unity games. We'll explore how to keep your games smooth and engaging. In game development, maintaining a responsive user interface is crucial. A frozen game leads to a poor user experience and player frustration. This happens when Unity's single main thread gets blocked by time-consuming tasks like network requests or complex calculations. Asynchronous programming allows these operations to run in the background, preventing your main thread from freezing and ensuring a seamless player experience. The core of asynchronous C# in Unity revolves around two powerful keywords, async and await. Understanding these is fundamental. The async keyword designates a method as asynchronous, allowing it to perform operations without immediately returning a result and enabling the use of await. The await keyword pauses the execution of the async method until the awaited task completes, without blocking the main thread, keeping your game responsive. A task object represents an asynchronous operation, acting as a promise that work will be completed, allowing you to track its progress. Asynchronous methods can return values using task, t, where t is the specific return type, such as task, int for an integer. Unity provides awaitable, a more efficient alternative to the standard .NET task. Awaitable instances are pooled, limiting memory allocations and improving performance. Let's dive into practical examples to see how these concepts are applied within Visual Studio and the Unity 3D engine. Loading a large file asynchronously prevents UI freezes. Task: run offloads file.readAll bytes to a background thread. Making a network request without blocking the game is essential for online features. Synchronous requests cause noticeable lag. Using Unity Web Request with async/await ensures these requests run in the background, allowing your game to continue processing input and rendering frames. The while loop with await task yield efficiently waits for the request to complete without consuming CPU cycles, ensuring responsiveness. You can implement cooldowns for abilities using async/await without blocking the main thread, providing a smooth gameplay feel. This attack method uses task delay to create a 2-second cooldown, resetting the can attack flag afterward, keeping the game fluid. For running multiple tasks concurrently, task.whenAll allows you to start several asynchronous operations and efficiently wait for all to finish. Now, let's cover essential best practices to ensure your asynchronous code is functional, robust, efficient, and maintainable. Avoid async void methods except for event handlers. They make exception handling difficult and can lead to unhandled exceptions crashing your application. Always prefer async task or async task, T for your asynchronous methods, as they provide better mechanisms for error propagation and handling. For CPU-intensive operations, use task, run to offload them to a background thread, preventing main thread blocking and maintaining game performance. Implement try-catch blocks to gracefully handle exceptions within your asynchronous methods, ensuring errors don't crash your game. Utilize cancellation token to allow users or the system to cancel long-running asynchronous operations gracefully, vital for loading screens or irrelevant network requests. When working with multiple threads, ensure thread safety using synchronization mechanisms like locks or thread-safe collections to prevent data corruption. Asynchronous asset loading is key to prevent hitches when bringing in game resources. Loading assets in the background keeps your game running smoothly. For performance-critical multithreading, especially with complex calculations, consider Unity's job system for highly optimized parallel processing. Be aware of potential pitfalls, such as freezing the UI, which can be solved by consistently offloading long-running operations to background threads. Unity API calls must always be made from the main thread. Use techniques like Unity Main Thread Dispatcher to marshal data back for safe API interaction. Avoid deadlocks by carefully managing thread synchronization and never blocking the main thread with synchronous calls while waiting for an asynchronous operation. While multithreading introduces overhead, profiling your code will help identify and optimize performance bottlenecks. Always measure before optimizing. By diligently applying these guidelines and understanding asynchronous C#, you can create responsive, engaging, and high-performing games in Unity. Thank you for watching. Keep practicing these techniques to master responsive game development and deliver exceptional player experiences.